So we're going to continue with our business mathematics videos. In this video, I'm going to clearly let you see, okay, the classifications of interest. What I mean is about the actual interest, the approximate interest, combined with the exact and ordinary interest, or rather the times, actual and approximate time, rather. So remember in our last video, in the approximate and actual and approximate time, we have this um, four different time factors which are possible for simple interest. So for one, we have ordinary interest. Okay, so we have two, if you can remember. So we have the actual time over 360 and the approximate time over 360. We also have the exact interest. The following time factors are used. So we have the actual over 365 and approximate over 365. And I have noted that the first factor, this one, actual time over ordinary interest, or 360 days, is known as the banker's rule, which is used rather when the problem does not specify what time factor to use. So it is also the banker's rule is also the common commercial practice, and that is the most favorable of all the time factors. Since ordinary interest is greater than exact interest, we have shown that in the previous video, and the actual time is greater than approximate time. So that will yield us the most interest. So let's try to prove that. Okay, by one example, shall we? So let's have it here. So John Lay borrowed 20,760 pesos at 3.5%. So we can say that this is 3.5%, okay, in decimal, simple interest on July 13, 2014, and the loan is payable on March 16, 2015. For the simple interest using the four forms. Okay, so for the four forms, it is payable on this date. We call this the maturity date, and we will be identifying which of them has the highest interest. So to identify which of them has the highest interest, so we need to solve them for them one by one. So let's make use again of our GAS method, the given, ask, and required method. So for the given, we know our first number here is the 20,000 rather, 20,760 pesos. This is your P, your principal. That's the amount John Lay borrowed. We have your rate. Let's make this in decimal form. So that's 0.035, right? So just move the decimal point to the left twice. And we have here our origin date. So again, the origin date is the date when you will be starting or when you borrowed that money. So that's your origin date, July 13, 2014. And your maturity date is March 16, 2015. That's of the next year. So we are asked specifically the I, the interest, but of four different time, what do you call that, or classifications of time periods. Okay, so since we don't have the official, what do you call that, the official letters or say subscripts for that, shall we just call I, the one is ordinary actual, okay, number two is ordinary approximate, number three is exact actual, number four is exact approximate. I directly use I used the numbering of the previous slide, okay, for us not to get confused. So let's try to answer this. Let me copy first the ones that I have given already. So we have given here P, rate, origin date, and maturity date, and what is asked of us. So for our solution, since we're given the origin and maturity date, so if that's given, we need to find or determine the D first, the days, which is in actual and approximate, because we need to use that in our types of interests. So let's try to start counting. So let's start first with July. So we will skip count by month. Okay, so July 13 to August 13, August to September, September to October, October to November, and so on. So let's start there. July 13 to August 13 of the same year, 2014. July, if we're going to count this time period, we will pass through July 31st. That's why it's 31 in the actual time and 30 for the approximate. Again, for the approximate, it's always going to be 30 no matter what. Actual, whatever is shown on your calendars, that's the actual time. August to September, again, August has 31 days, so we will pass through that August 31, 2014, so that's 31. Approximate is 30. For the September, 13 to October 13, September, we don't have a September 31st, so it's only September 30, so 30 days for actual. Approximate is still the same. For October 13, 2014 to November 13, 2014, we will pass through October 31. Okay, so that's 31 days for actual. The same is true for the approximate. For the November 13 to December 13, there is no November 31st, so therefore November 30 will be actual, approximate the same. December 13 to January of the next year rather. So December has 31 days, so that's it. 31 for actual, 30 for approximate. For January, we also have 31 days until Feb 13, and now Feb 13 to March. We will pass through February here until the end of February. So we must ask ourselves: is this year a leap year? Probably not, because 2015 or 15 is not a multiple of 4. So it's not a leap year, therefore February has only 28 days. And approximate, take note, including February, approximate will still stick on the 30 days. Okay, no matter what, even if it's February. So it's still 30 days. Okay. Now, our maturity date is March 16. We ended on March 13, so we need to add it up. March 13 to 16, we know that it's 3 days, no doubt about it. So that's gonna be strictly 3 days. So let's sum them up for the actual. Maybe you can sum them up using your calculators. Also for the approximate. Okay, what's the answer? Okay, so I think this is the number that will come out. 246 days for actual and approximate 243 days because we're rounding up. We're rounding off to 30 days in the approximate, so it's much lesser because we didn't take care of the third of the one's 31st dates. So given this total days, we have already our D. So now we can calculate actually. So using our original formula, I equals PRT. So we will just tweak that with our time period 1, 2, 3, and 4. So voila, this is what will happen. So I equals PRT. Thus, we have for number 1, ordinary actual days. That's 3246 over 360. Ordinary. Ordinary approximate, 243 over 360. For number 3, 246 over 365. For number 4, that's 243 over 365. And substitute them all. Okay, so the P is taken from here, our R is taken from here, and all the values are taken from for the days. It's here, total and approximate. Okay, so maybe I'll give you some time to work on your calculators on this. We have 4. So we have for the first time period, second time period, third time period, and fourth time period. Okay, you can start. Go. Okay, so I think you have paused already your video, so we have the answers now here. So for number 1, we have our answer. That is 496 pesos and 51 cents. Okay, so that's your number 1. For number 2, we have 490 pesos and 46 cents. That's for your number 2. Number 3, we have 489 pesos and 71 cents. And number 4, we have 483 pesos and 74 cents. So notice here that the one with the biggest interest gained or earned is okay. So we can see here this one is the least rather, the least. This is the one after the least. This is good. This is the best so far. Okay, so I think we need to follow the banker's rule. So thus, by the banker's rule, it is said that the first factor is the one that gains the highest interest, and indeed, it is really true that in here it is number 1 that gained the highest interest so far. Okay, and you can see that the interest gain is becoming lesser and lesser as we go to number 4. So you can see the number 4 is the one least, and it's getting lesser and lesser and lesser. So therefore number 1 indeed is the one that is gaining the most interest. Okay, so that's the end for this video. Thanks for watching. Again, this is for the classification of interests. If ever you have some questions, kindly just rewatch this video and don't forget to like and subscribe. Thank you very much and see you. Bye.